Nucleophilic addition in skeletal formula may sound like an unnecessary complication, but with exam boards like OCR being such big fans of skeletal formula and the rising circumstance of off-spec application coming up in exams, being able to interpret skeletal mechanisms as well as trying them out for yourself is an excellent strategy for revision. Let's have a look at an example of nucleophilic addition using a ketone of butan-2-one and NaBH4, aka sodium tetrahydridoborate. Alright, so the first thing I need to do is draw out my organic molecule down here. So I need to draw the butan-2-one clearly in skeletal formula. So I've got my 4-carbon chain, there we go. And I'm going to make sure that my connections here for the ketone group are done really clearly. I'm going to connect up really well there, no gaps at all, and I've got my oxygen at the top just up here like so. Okay. Now I'm also going to show my hydride nucleophile, which is an H- ion down here that you can see in the top mechanism as well, and we're still going to show that even though we're doing skeletal for this mechanism, because whilst we don't show carbon to hydrogen bonds, we still show hydrogens where appropriate in skeletal formula, like alcohols, like in amines, for example, and here we still need to show it because we've got this nucleophile attacking the carbon with the delta positive partial charge. I'm also going to put those partial charges on. I'm going to put them in exactly the same positions so you can see exactly what's going on here as well. There we are. And what I'm also going to do for you at this stage, not something I would do in the exam, but I'm going to put numbers just on, as you can see in the top structure, next to the carbon atoms, so you can track exactly where these carbons are in relation to the original structure. So I wouldn't normally do that in an exam, because I don't want to clutter up or put some potentially inaccurate labels onto my mechanism outline. But I'm doing it here just because I think it introduces some clarity for you. Now what I need to do is I need to show my curly arrow movement, and nothing changes here. So my curly arrows are going to be going to and from the same locations. So we're going to start at an electron pair source, which for example, for the hydride ion down here is going to be its lone pair. Make sure you stack the lone pair and the negative charge together, because when you move to multi-atom nucleophiles, it's going to be quite important to make sure that you're pairing that negative charge and the lone pair together where appropriate. Not saying that all nucleophiles always have a negative charge, I'm just saying when they do, pair them up. So I'm going to show my curly arrow going from the middle of the lone pair straight up to the carbon atom. It's that bend in the line for the skeletal formula, and I don't think I could have done that any more clear. And then my next curly arrow is going to go from one of the lines of the C double bond O for the ketone group onto the oxygen atom at the top like so. And you can see if I zoom out here, it's exactly the same as the previous setup and layout. That moves me on to the intermediate. Now this is where I think things are going to be a little different for you, because we've just introduced a CH bond. So at carbon number 2, we're now going to have a carbon bonded to a hydrogen. But because this is skeletal formula, I'm not actually going to show that. I suppose you could, because it wouldn't cause for the structure to become ambiguous in any way, but here I'm going to stick to strict skeletal formula for you, and I'm not going to show that new carbon to hydrogen bond at carbon number 2 that we've just created. So let's have a look at the structure of our organic compound at this stage. I've got my same 4-carbon chain, so I'm not going to change the chain length or anything like that. It's not like I've used a nitrile. And carbon number 2 is still single bonded to an oxygen, so I'm still going to have a bond going up here like so. I'm going to put the oxygen there. I'm going to give it a negative charge. I'm going to put its lone pair on. No differences there. And then actually at this point, that's it for my organic molecule. I'm not going to show anything else on there, which might make you feel a little uncomfortable at first, because there is a temptation here to add a little bit more to it, but I'm not going to show that new CH bond, as I've already mentioned. Now the next stage of this is to have the water molecule. I am still going to show this. So just because we're using skeletal doesn't mean we're now not going to show this particular section of our mechanism, because if you think about alcohol functional groups and carboxylic acids, we still show hydrogens there, particularly oxygen bonded to hydrogen. So I'm definitely not going to lose any of that. And I'm going to put on my partial charges here, just as I did do before. And I'm going to then intercept here with some curly arrow movement. So here with my curly arrow, I'm going to go from this oxygen right from the middle of its lone pair. So if I zoom in there, you can see exactly where I've started from there, the middle of that lone pair. And I'm going to go straight up to the hydrogen with the delta positive partial charge, and then I'm going to break this bond here. I'm going to go straight on with a curly arrow there from the middle of the bond onto the oxygen. That takes me then to my final structure. So again, sticking with strict skeletal for this. Let's get our final structure shown. Just going to move all of this over to the left a little bit. There we go. Now the final structure is going to be the alcohol, but you must make sure that you don't forget this little important factor here, which is the OH minus. Where we get the OH minus from is this stage in the mechanism. I'm going to create then my alcohol product. So I've got my 4-carbon chain. There we go. And on carbon number 2, I'm going to go back through and let's number up the carbons so we can see everything we've used here. So I've got carbons 1, 2, 3, and 4, and 1, 2, 3, and 4. There we go. So I've changed the pattern slightly in the way that the chain is zigzagged, but you can see exactly where the carbons are by using the red numbering here. So that's the main reason why I did this. And we can also see now, I'm going to just chuck alongside this here, the OH minus to complete my answer to the mechanism. Thank you very much for watching, and don't forget, if you found this video helpful, I would really appreciate it if you could give it a like before you go, and consider subscribing to stay updated. And until next time, happy revising.